Let's look at the mind map of alkene preparation and reaction. Okay. So we look at the preparation of alkenes first. Okay, how to prepare alkene? One way is dehydration of alcohol. Means you eliminate one molecule of H2O. Okay, another one is dehydrohalogenation. Means you eliminate one hydrogen and halogen. Okay, for these two, that is dehydration of alcohol and the dehydrohalogenation of haloalkane, we apply Sayzeff's rules. Okay, so later I'll explain more about Sayzeff's rules. Okay, so the type of reaction is elimination reaction. Okay, now let's look at our product. Okay, you can see here, I purposely break the double bond into two, or I divide them into two, and then I label the carbon number 1 has more hydrogen, and then the carbon on the left, carbon number 2 has more alkyl group. Okay, so why? Because it's according to the Sayzeff rules. Okay, another one, I also need to label this because later I apply Markovnikov's rules. Okay, so let's go one by one for reaction of alkenes. Okay, for reaction of alkenes, it can undergo hydrogenation. Hydrogen with catalyst, it can be platinum, nickel, or palladium. Another one is halogenation. You can use Cl2 or any halogen. Okay, now if you see halogen, but if you see water, bromine water, okay, so when you have bromine water, it obeys Markovnikov rules. If Markovnikov's rules means electrophilic will go to more hydrogen. So bromine is electrophile, so electrophile will go to more hydrogen carbon. Okay, next one is hydration, where we add H2O. Okay, so for this part, we need to apply Markovnikov's rule. So hydrogen go to the more hydrogen carbon. Okay, and next one, we also have HBr. Okay, for HBr, we also apply Markovnikov's rule. That is, the process name is hydrohalogenation. So again, same thing, hydrogen go to more hydrogen. Okay, if we have HBr, and you can see here H2O2 or CH3OO, CH3, the peroxide, then you must apply anti-Markovnikov, meaning that this time hydrogen go to less carbon, less hydrogen, carbon, and it's only for HBr. We don't use HCl. Okay, now next one, that is ozonolysis. Okay, for ozonolysis, the first one is we must add ozone followed by zinc or in water. Okay, for this part, you must label 1 and 2. Okay, because this is a process that you have to follow the step. So you must label Roman 1 and Roman 2. And if you don't want to use zinc or water, you can always use dimethyl sulfide. Okay, and then you can see what we do with it is we just break up the carbon double bond. Okay, later there will be more example. Okay, if you see that there's a dilute KMnO4 potassium permanganate is in basic condition, and it is cold, it's actually a Bayer's test where you will get diol. And for MnO2 is a brown precipitate, you must label arrow going downward, means it's precipitate. Okay, if you have hot potassium permanganate, okay, then you will get different product as well. Later I'll explain. Okay, so this is a summary table of the oxidation process. Okay, let's go one by one. Go to Sayzeff's rules. Okay, as you can see here, we can eliminate both. Okay, and we will still get the same product. Okay, these two are the same. Okay, now we look at another one. Okay, so this time, let's say I eliminate on the right. Okay, so when I eliminate HCl on the right, you can see here, the H and Cl is gone, has been eliminated. So what happened is, I will see how many alkyl group I get. Okay, for this part, I only have one alkyl group. If I eliminate the HCl on the left, I will get two alkyl group. So two alkyl group is the major. So you must label major and minor for elimination reaction. Okay, then next one we also have, when we look at this one, it seems like we can only eliminate one choice only. Okay, however, if we rearrange, then we can get major product to get two alkyl group. Okay, for the rearrangement, you can refer to the mechanism why it can undergo rearrangement. Okay, but what I usually will tell my student is, first time you draw a double bond, and then you draw the double bond next to it, and then you try to find out how many alkyl group you can get. Okay, but you cannot go until this part. Okay, you can only move once only if you want to do it faster. Okay, now next one is the addition reaction. Okay, where we follow the Markovnikov's rules, that is hydrogen go to more hydrogen. This one you don't have any problem. Okay, so you don't, for Markovnikov's rules, you don't have to label major and minor unless the question say it has a mixture of product and ask you to identify major or minor. Okay, when we look at this question, again the same thing. We would expect that we will get OH here, just like this part. Okay, however, the answer has another one. That is the tertiary alcohol. Means it also has rearrangement. Okay, so you can refer to mechanism. Another way that I would do is, I will try to shift it both. So I can, but only once, you cannot go until the last one. Okay, and then you will try to see, can I get a tertiary? Because here I will get a tertiary, secondary. If I can get a tertiary, I will shift. If I don't get a tertiary, just only one product. Okay, now the last one is oxidation. Okay, oxidation is easy. You just break up the double bond and then combine with oxygen. Okay, the only thing that is different between potassium permanganate and ozonolysis is the hydrogen part. If for KMnO4, it will change to OH. If it is ozonolysis, hydrogen remain unchanged. Okay, if you have one carbon, two hydrogen for hot acidified permanganate, then your product will change to CO2 and H2O. But if this is a ozonolysis process, then your H remains the same. It will produce aldehyde. Okay, so that's all for the mind map of alkene.